Okay, the for repetition statement. If the loop's condition uses a less than or a greater than sign instead of a less than or equal sign, or vice versa, can be the result of an off by one error. Okay, so specifies the number of times to do something. We'll talk about this is called a boundary error, when you meant to say less than or equal to, but you only put a less than sign. And I showed you that boundary error earlier when we looked at the time, when we left out the 12 o'clock error. That's an example of a boundary error, which is a logical error. So in the for statement, header contains three expressions: initialization, condition, increment expression. The increment expression for the for loop acts like a standalone statement at the end of the body of the for statement. Place only expressions involving the control variable in the initialization and increment sections of the for statement. So we'll see how that works in a moment. So for example, that's their example. They replaced their while loop with a for loop. And I'll show you how we can take this example, which said to do it while students is less than or equal to 10. I can replace this with a for loop. So if I do this, I can say for var students equals 1, students less than 10, add 1 to students. That'd be a for loop. Now by doing that, I can eliminate that. I no longer need it. I can eliminate that. I no longer need that either. So I eliminate 2 lines. So that's a for loop. A for loop is specifically designed to do something X number of times. It's a special type of loop. And this will convert just as easily. If I do this again, there it is. So it's a special type of loop that does something X number of times. And it allows you it streamlines the whole process of when you want to do something X number of times. Or a while loop is the one to do. Now the pseudocode said while inside the pseudocode, but as a programmer it said to do it while it's less than 10. That kind of screams for loop. So it would have been okay for me to translate that from what they put in the pseudocode of a while loop to a for loop, just because the pseudocode is not language specific. It's language independent. So when I go from the pseudocode, which is language independent, into the language specific, it's okay to make changes if that change will have no effect on the logic, but will actually improve performance, which would be the case here. So again, var, as the keyword is for, the control variable is counter, initialized to 1. Counter is less than or equal to 7 in this case. Increment counter by 1 each time. And that's a fully self-contained loop. The 3 expressions in the for loop are optional. You don't have to put them in there. You can leave them blank. If you leave them blank, though, you wind up with an infinite loop, which is not generally a good idea. The initialization, loop continuation conditions, portions of a for loop can contain arithmetic expressions. So when I say it's optional, that means if I wanted to, all I actually need to do is that, 2 semicolons. And this will work just fine, except it will create what we call an infinite loop, because there's no condition to stop it. So although this is legal, you rarely do it. I mean, hardly ever would do something like that. Part of the script in which a variable name can be used is known as the variable scope, where it can be used. So variable scope is generally where the thing is available to be used. So for example, when I moved students from up here to down here, what that meant is that student could only be used inside here, inside this body right here. It's not available anywhere else. So while passes and failures are available elsewhere, students isn't. So if I tried to use that and said, okay, most likely going to give me an error message. Okay, so it probably will initially work and eventually get an error. Okay. Worked. Shouldn't have worked. I'll tell you why it worked. It worked because JavaScript has a bug in it. That's why it worked. This is a known bug in JavaScript. It doesn't actually work. In most other languages, if you did this, like Java or something, students would not be accessible down here because it's created in this block. And a scope of a variable means a life or where the variable can be referenced, and you can look at the values. It normally can only be looked at where it's declared. Now, we could try result, but I'm not sure that may be caused by the same bug. So I'm just going to try that and see, because that's declared inside of the for loop. So I'm hoping that will work correctly. Which is the last value entered. So it actually, that bug is still there. This shouldn't work. I should not be able to reference result outside of this for loop. That shouldn't work. That's a bug that's been there a while. They're violating scope. Right? So this for loop is a block of code. I'm declaring this variable in here, and that means that it should not be available outside of that block. But they're violating that scope rule. Though the value of a control variable can be changed in the body of the for loop, you shouldn't do that. It's a mistake. So what they're saying is that I can go in here, and in this for loop, I can say students minus minus 1. And that's legal. It'll work. The problem is, well, first of all, this is going to create an infinite loop. But even if I did a plus plus, is I'm messing around with the logic that the for loop is doing, and that's a bad idea. You shouldn't do that. It's just a bad idea. You can do it. It's just not a good idea. Modify that. This whole thing shows you how the pseudocode for it. The counter starts at 1. Counter is less than or equal to 1 true. Print this out. Add 1 to counter and go back. And as long as that's the case, it's going to keep printing this out until eventually it's going to hit 7 and it'll come to the false part. Any questions so far? No questions? Okay. Then let's go on. Not using the proper relational operator in the loop can cause a problem downward. Yeah, so that's a logic error. So if you do something like that, is less than or equal to, it's a logic error because you're going in the wrong direction. Okay, looks like we got a question on the for loop. For the scope, do you need to indicate use strict? Let's see. That might be the problem. I know that a while back that this became an issue, and it was actually a JavaScript error, but it could be that that's how they resolved it. Use strict is like a Visual Basic thing. I don't know if it's used in JavaScript too. I'd have to research that. Have you used that before in JavaScript, Hal? Huh, okay. What do you just type down here? Use script or something? Oh, that's like that. Try it. No, I didn't like that. In quotes, use strict. So I haven't actually seen that before. Let's see what happens. I was told that that was a bug. It still gave it to us. Was there a function called use script? If you have some more information on it, Hal, send it to me, because it may be that it's not supported by all browsers. Now, within a function, scope rules do work. Where I've seen that they don't work is within a loop or an if statement. That's where I've seen the scope rules not working. And when I had researched it years ago, it turned out it was an IE error, and the other browsers decided to use it as well because the problem was that programmers were now starting to assume that the scope would work that way, and they were writing code. They didn't want to break that code, so they just allowed it. And maybe the use strict was for people that don't like to violate code rules as scope rules. They also program in Java and in C++ where this is not allowed. That's definitely not allowed. But yeah. Anyway, so here's another example using a for loop. And in this particular case, all it does is it sums a bunch of numbers, some even numbers. And they simply do that by saying plus equals 2, so that it starts at 2, and then it adds 2 to it every time. So it's always going to sum those numbers there. And you'll get that number 2259. And that one should be on my website as well. Yeah, so 2 is 100. Those statements preceding a for statement and in the body of the for statement can often be merged into the for header. Avoid doing so because it makes the program more difficult to read. Yeah, so I don't know if they have an example on that. I don't even know that if I even want to give you an example on that, but I mean, you could do weird things here. What do you do here? It's not a real good example, but for example, you could initialize more than one variable in here. For example, I could say, comma, test equals 0. That's allowed in a for loop. But you shouldn't do it because the for loop should be limited to just doing something X number of times. You shouldn't be putting program logic into the for loop. So, but for loops allow you to do a lot of that stuff, which is not really considered good structured programming. Use strict can be used at the top. Well, I tried that; it didn't seem to work. Within each function. You know, though, Hal, I never saw this scope problem inside the function, so I'm just wondering. Well, we'll try it. I mean, one of the things we could have done here is we could have created a function out of it and said, function, do it. And then you can say it's on page load, or on load. I think it's on load equals do it. Maybe that'll work. Nope, didn't like that. On load or on load. Loaders, it might be something else. It might be on. Oh, it's in the wrong place for starters. Of course, if you do this, you can now also move the script back up to the header where it should be. This is really the way it should be done. Let's see if this works. No, it still didn't work. Yeah, I'll play around with it too. But yeah, I mean, that's interesting because there have been scope problems for a while. See, in this example, calculating compound interest. Now, this is kind of an interesting example here. It hard codes some values, 1,000 and an interest rate, and then it uses a JavaScript program to print out. Essentially, I believe it's going to be an interest table, if I'm not mistaken. Yeah, it basically does that. Figures out how much interest you would get based on each year. And you can actually do similar things like this to figure out what a mortgage payment would be as well. You can modify it. You could prompt the user to do some stuff like that. This particular case, well, actually, figuring out interest is pretty straightforward. Figuring out a mortgage payment you can do as well. You have to use one of the math functions to get the future value. Okay, it looks like that. Power. I believe you use this to figure out a mortgage payment, if I'm not mistaken. Yeah, they're not showing you that. It's one of the math functions of the future value. I think they have an example that creates a mortgage table too, an amortization table. Okay, next let's look at the switch statement, which tests a variable for a particular value. Switch statement is not a loop of any kind. It's more like an if statement, but it's structured differently. So, but we'll look at that as well. And it's used when you're looking at one value, one particular value, and you're trying to say, is it equal to this or this or this or that? So the switch statement consists of a series of case labels and an optional default case. When control reaches a switch statement, the script evaluates the controlling expression in the parentheses, compares this value with the value in each of the case labels. If the comparison evaluates to true, the statements after the case label are executed in order until a break statement is reached. We'll see some examples on this in a moment. The break statement is used in the last statement in each case to exit the switch statement immediately. The default case allows you to specify a set of statements to execute if no other case is satisfied, usually the last case in the switch statement. Each case can have multiple action statements. Braces are not required around this, so the switch statement is sort of a different animal in some ways. Breaks a lot of usual rules. The break statement is not required for the last case because the program control automatically continues to the next statement. Having several case labels listed together with no statements between them executes the same set of instructions for each case. So like a bunch of ORs. Okay, so in this example here, so it gives you an option of 3 possibilities. Put in 2. Let's look at the source here. So here's our switch statement. As it gets the prompt, and here's the switch statement. Switch choice, which was entered there, a loop. So case 1, which would be if it's 1, it sets some variables to different things, and then it says break. And this break is very important because the case statement is sort of what's known as a fall through, meaning that as soon as a case is met, it will just fall through all the other cases and do everything in the cases unless you stop it. And the break is how you stop it. So if I removed this and tried to run it again and I enter a 1, instead of getting a numbered list, I'd get a lettered list. And that's simply because I entered 1, but I didn't have a break here, so it fell through and did the case 2 as well. And so it did all this stuff, but then it kept on going and did this, which overwrote what I did in 1. So you have to have the break there. That ends that case. That's how the case is ended. So there's no curly brackets. It's got just the break. And then it will enter all the different output. If you enter something invalid, then it gives you an error message. I'm pretty sure that's what they've got here as well. Enter 1. If you enter a different one, if you enter 1, you get a list items, a numeric list. If you enter 3, you get Roman numerals. And again, the case looks like a nested if, else if sort of thing. It's got case A, true, do something, break. And then case B, do something, break, and so forth. So that's the way a case generally looks like. You know, a case can be done as a if, else if you wanted to do it that way. It's just that under certain circumstances, it's actually more efficient to use a case statement when you've got a situation where you're looking at one value. Switch statements are very often used when processing menu selections. That's a pretty common use for them. Processing menu selections. Okay, so the do while loop is the next loop, and it's essentially the same as the while loop, except the condition is checked after all the instructions are executed instead of before. Which means that a do while loop will always execute at least once, whereas a while loop will only execute if it's true to begin with. So it may execute 0. A while loop executes 0 to many times. A do while loop executes 1 to many times. And that's really the only difference. Otherwise, they are the same. Say do while loop looks like this here. It will say do, and it will do everything here. While counter is less than or equal to 6. And it checks the condition afterwards. So if counter is 7 to begin with, it'll still do this once, but then it won't do it anymore. Right? Okay, so let's look at this one here. Do the do while loop. So now if I took this thing and I made some changes to it, and I simply change this to a 7, I still get that. Right? However, if this were a while loop instead, you get nothing. Because in the while loop, the condition is checked first, and then it does the commands. In a do while loop, it's just the opposite. It does all the commands, then it checks the condition. It's post-condition processing. Which means the do while loop always does whatever's in there at least once. And it depends upon how you want to do something. A lot of times you do want to do something at least once, and depending upon what happens, what the results of that processing is, you may want to do it more than once. So do while loops are actually pretty good for sentinel values. So you look at some of the examples we did with the sentinel values, and I don't think I have any of those anymore because we got rid of them. But what we did with some of the sentinel values, which is where you had input until they didn't enter something correctly, or they entered the sentinel value, that worked. Let's see. If we go back, look at one of these while loops. That might have been a sentinel value, right? Yeah, -1, right? Look at view source. Their view source. You'll see how this could have been done a little simpler. So here I do the prompt. However, if I move this there, but one of the things I don't need to do is I don't need to do the prompt twice. I would take the prompt and I would add it at the beginning, and I no longer need to do this twice. I only need to do it once. Because now it's going to be checked down here. And obviously, if you're doing it once outside of the loop, and then you have a loop that keep doing it, if you want to keep doing it, then that kind of screams of a do while loop. So a do while loop, when you have something that you want to do at least once, and you may want to do it more than once, then it's a do while loop. If you have something that you might want to do never, then then you should use a while loop. So it's whether you want to check the condition pre or post processing. And again, usually what you do is you'll see the actions and a condition, and then if it's true, it goes back up to the top, meaning it's going to continue those actions again. Any questions?